without penny, are you ready?
Not yet.
Okay, not yet. Joseph, are you ready? Joseph, I'm not getting you. Joseph, are you ready? Okay. What about St. Paul and okay. Mary Thatcher, your hand is still up. Mary Thatcher, your hand is still up.
So I just forgot to lower.
Okay, good. Let me ask, is Kesselibas on? Kesselibas, in case you're on, can you have your hand raised? Okay, Assumpta. Assumpta, unmute. Where is Assumpta? What patience are you on? Okay. Okay. Anyone who is ready now to present, have your hand raised. Anyone that is on, because I'm not seeing some presenters on. Auma Beatrice, are you on? Auma, in case you're on, can you raise up your hand? Patience Mukisa, in case you're on, have your hand raised. Who else? Okay. Patience Mukisa, Auma Beatrice, Laban Samuel, Nwasasila Amon. Are you people on? Okay. Yes, Anita. Unmute.
Also, I don't have the right.
Okay. Anita, keep your hand up. Okay, good. Anita, you're good to go.
Okay, I'm presenting number 31. Good morning, first of all. It's all about matrices. So the question, though it's not clear, it was given that A is equal to 3x, negative 6, then x minus 6, x plus 2. That is the matrix of A. Find the value of x for which the matrix is singular. So we should first of all know that a singular matrix is whose determinant is 0 and has no inverse. So this one, it's said to be a singular matrix. So we are going to use the knowledge of looking for a determinant, where the determinant, we get this one, 3x and x plus 2. You multiply them, then you subtract this side. So you subtract the diagonals, the product of the diagonals. At first it will be this one, then second this one. Then 3x into x plus 2 minus -6 into x minus 6 will be equal to 0, since a singular matrix has a determinant of 0. So we will negative. You open, then 3x squared plus 6 minus 36 is equal to 0. X squared plus 12x minus 36 is equal to 0. Then our product will be 108 and the sum will be 12. Then when we split 12x, we are going to get -6x plus 18x. So 3x squared minus 6x, since we've split the 12x plus 12 plus 18x minus 36 is equal to 0. Then we look for the common factors. The common of 3x squared minus 6x is 3x into, you divide both sides by 3x, that is x minus 2 plus 18 into x minus 2. So you divide 18 by both sides. Sorry. So we put in the knowledge of quadratics. So we put in the knowledge of quadratics. So we had reached at this step. 3x squared minus 6x plus 18x minus 36 is equal to 0. Then 3x into x minus 2 plus 18 into x minus 2 is equal to 0. So you pair them. 3x plus 18 into x minus 2 is equal to 0. So either 3x plus 18 is equal to 0, where x will be -6, or x minus 2 is equal to 0, then x will be 2. So either x is equal to -6 or x is equal to 2. That's it. So any questions?
Raise up your hands in case you have any question. In case you have any question concerning. Okay, yes, Judith.
How are you getting the product and the sum?
Okay. How are you getting that?
Okay, with the product, you're going to get the coefficient of x squared. You multiply it by this negative. So the product was supposed to be negative. This was a mistake, because it will be 3 times negative 36. So it will be negative 108. Have I answered your question?
Judith, has your question been answered? Okay. Precious?
Thank you, sir. Anita, I'm sorry for disturbing you, but I had a network issue. The part that I understood was the diagonal minus the minor diagonal, then the step that followed. But the remaining part, I'm kind of getting confused because I got a network problem, so it just refreshed. Could you please help me out?
Okay, pardon your question.
I'm requesting for more explanation after the subtraction of the major and the minor diagonal, the following steps after finding the adjacent.
Okay, we are not looking for the adjacent. We are just looking for the determinant. And the determinant is got by subtracting the product of the first diagonal, 3 times x plus 2, and this one negative 6 into x minus 6 is equal to 0. Since the singular matrix, it is said it has a determinant of 0 and has no inverse. So with 3x squared plus 6x, hope you know how I've got that one, minus 6x plus 36 is equal to 0 as the determinant. So 3x squared plus 6x plus 6, yes? 36 is equal to 0. So squared plus 12x minus 36 is 0. So you realize that this one is a quadratic equation. So we bring in the knowledge of quadratics. So the product will be negative 108. Then the sum will be 12. And we will split this 12x. It will be negative 6x plus 18x. So 3x squared minus 6x plus 18x minus 36 is equal to 0. So we look for we pair them first, and we are going to look for the common factor. So the common factor of the first pair, this one and this one, is 3x. Then 3x will be divided by 3x divided both sides of these numbers, and it will be 3x squared divided by 3x, getting x, minus 6x divided by 3x, getting a 2. So we look for a common factor of the second pair, 18x and 36, which will be 18. And 18 divided by 18x, 18x divided by 18, we will get an x, then 36 divided by 18, getting a 2, is equal to 0. Then get this one, you add to this one. And the other one is common, so it will be 1. So 3x plus 18 into x minus 2 is equal to 0. So either 3x plus 18 is equal to 0, getting our x as -6, or x minus 2 is equal to 0, getting x as a 2. So either x will be -6 or x will be 2.
Okay, thank you. Let me see whether are there people with some questions concerning the number. Okay, okay. Sarah, unmute. Sarah, unmute.
Excuse me, teacher. Like on the part of product and sum, I request that you explain to me, because now I'm confused about trying to divide 3 by all the terms. Like 108, because now our product I see 36 and the sum is 12. So now how do we come about to get 108?
Okay, I'm going to throw some light on quadratics. Okay, so I'm going to get back there. Cynthia.
With the product 3.
Yes.
Are you getting me?
Yes,
So,
go on.
3, you'll multiply it by the.
Excuse me, sir.
-36.
Excuse me.
8. Have I answered your question? Am I communicating?
Okay, Anita, where you are, there is a lot of noise. Okay, let me hear from Lena, unmute.
I would like to ask, why is it that I'm using a different method for completing squares and I'm getting a different answer?
Okay, why I beg your pardon?
I used a different method for completing squares and I got a different answer.
Okay, we are going to go to that. But one, you might not have done it in the best way, but we are going to go through it. No worries. Okay, then academic hustler, you are the last one.
Okay, thank you, teacher. Having got the product and the sum, the product being -108, I'm a little confused how she came up with the next formula being 12x minus -6x plus 18x.
Okay.
Okay.
Okay. Okay, Anita, first go on.
With this one, 12x is equal to -6x plus 18x. It was showing that the 12x before this one, the 12x was split to be -6x plus 18x. Is that fine? Or
Okay.
Am I clear?
Anita, you are clear?
Yes.
You are clear?
Okay.
Okay, but I'm going to throw more light concerning that section of quadratics. Okay, Anita, may I request you to end the screen sharing such that I can share something?
Okay.
Okay. Let me first share my screen here. So I'm noticing some of you are still having some chance. So when it comes to a quadratic, oh, someone is having. Can someone mute? When it comes to a quadratic equation, we have 3 ways, or we have 4 ways you can solve it. One way is using the factoring method. So you can solve a quadratic by factoring. We can use the bulldozer method. We can use what we call a factoring bulldozer. We can have the completing square. And then lastly, we have the graphical approach. But allow me to have this completing square even put in another color to show you how important it is. So a quadratic equation is given in this form: ax squared plus bx plus c is equal to 0. So for whatever quadratic equation you have, always you have to first find out what is the coefficient of a, what is the coefficient of x, and what is the c. So those are the key things you look out. So always to obtain your sum, your sum is equivalent to where you have b, is the coefficient that is sitting in the position of b. Then to obtain your product is given by a times c. So to get the product is a times c. Take an example. If at all this is my quadratic equation, ax squared plus, okay, let me start with 3x squared plus 11x plus 6 is equal to 0. Can we identify, let me allow you to, okay, let me allow you to unmute such that we go together. You are allowed to unmute. Can someone tell us what is your coefficient of x squared? What is a, what is b, and what is c? So what is our a? When you compare the original equation, a is 3. Good. What is b?
11.
B is 11. And what is c? 6. Good. So to your sum for this equation, we have said that our sum is equal to b. So our sum will equal to what?
11.
11.
11. Good.
11.
What? 11. Then to get the product we have said you multiply a times
18.
what? C. So can we multiply 3 times 6? 18. 18. So now our next task is to find out 2 numbers. We multiply to get what? 18. Then we add to get 11. So one of the ways we can do it is by us looking at the factors of 18. Can we mention some of the factors of 18?
2.
2 and
2.
okay.
1.
2 and 9. Another
3.
3 and 6. Do we have any other?
No.
Yes.
1 and 8.
1 and 18.
Yes. So now, okay, I've allowed you to mute, but make sure your background is okay. Now, okay, let's first mute. I don't want to mute you now. Let me first mute you now. So now, after you identify what is that pair, which when I add, I get 11, I multiply, I get 18. So which pair are you noticing? Any of these pairs. Which when you
2
add,
and 9.
you end up 2 and 9. Are we noticing 2 and 9? Yes. So meaning that
teacher.
it is the 2 and 9 that we shall use. So meaning where you have your B here is where you are going to replace that 2 and 9. 2 plus 9 is equal to 11, and 2 times 9 is equal to 18. So that is why when she was solving Anita, that's why she had to multiply the A and the C. At times, because we are used that always the coefficient, when I have this number, x squared plus 6x plus 9 is equal to 0. What is our coefficient of A?
1.
It's
1. Good. Then the coefficient of B is what?
6.
6. Then the coefficient of C is what?
9.
9. So what is our sum?
6.
6. And then what is the product?
9.
9.
9. But are you noticing that still you multiply A times C? So when you multiply 1 times 9, you end up with 9. That's why whenever you find that the coefficient of x here is not a 1, that's why always the teachers tell you that just take it as the 9, the way it is. But whenever it is there, you have to multiply to get the product. Hope now that point is solved. The next one I want to look at is the second method we call the bulldozer. So the bulldozer is given by x is equal to negative b plus minus root of b squared minus 4sc divided by what? 2a. You may not need to cram this formula. Always ask for what you call a logbook. Whenever you are entering a math exam, always UNEB provides a logbook. So this formula is always given in the logbook. So you just check out in that logbook in case you have forgotten it, and then you check it out. So always first remember or first find out what is your B, what is this, what is this, what is this, and what is A. Then you substitute in. But the method I want us, the one I'm going to drill on much, is what you call the completing square. So here is where I'm going to drill. That's why even I'm using blue, completing squares. So when it comes to completing square, this is one of the most common methods that they specify for you to use. Whenever you find a quadratic equation and they have not specified the method to use any method you understand that is easier for you. Always look out for the easiest route to use. However, whenever they specify that complete the squares, meaning that you have to look at that method, that is the method they want you to use. How do we use it? When it comes to a completing the square, we know very well that our quadratic equation is always given in this form, bx plus c is equal to 0. We have two kinds of squares. The one type is what we call a perfect square. So when you are working out a quadratic equation, you are going to first check, is my square a perfect square? So you can check whether your square you're given, check whether it is a perfect square. How is the perfect square? How does it look like? A perfect square looks like this. It looks in this form, x plus p, all of it squared. This is what we call a perfect square. When I find x plus 2, all of it squared, this is a perfect square. So that's what you call. So always you first look out for it. And how do you know that this square is a perfect one? To get a perfect square, you get c must always equal to 1 out of 2b, but all of it squared. Are we understanding? You get c is equal to a half b, all of it squared. That's what we call a perfect square. Any quadratic equation that satisfies this condition is a perfect square. I want us to check an example. I have x squared plus 10x plus 25. Can we identify together? what is our value of A? What is the value of B and C? What is our A?
1.
Good. What is the B?
10.
And what is C?
25.
25. Good. So now I'm going to check this condition. Is this a perfect square? So my perfect, I will say C is equal to a half times my B, which is 10, all of it squared. So what am I going to do? Always remember body mass, deal with what is in brackets. By 2, 1, by 2 is 5. Then I come, I ask myself, this is the same as what? 5, all of it what? Squared. I check, what is my C? Is 25. I ask myself, is 5 squared the same as 25? Is it the same?
Yes.
Yes. Meaning that square, meaning that quadratic equation gives a perfect square. So whenever you find that it is a perfect square, even you can first clap a bit and say, now this one is very fine. So what do? When it is a perfect square, that means that this quadratic equation, x squared plus 10x plus 25 is equal to 0 is a perfect square. Meaning, what am I going to do? Always, we add and subtract this C. So what you have as your C is what you add and subtract. So what am I going to do? I'm going to have this as x squared plus 10x then plus 25. So you add the C and then you subtract the C equals to 0. So when I say C minus C is the same as 0. So you have not created anything. It is the same equation. So our C, what do? You carry it the way you have it. So our C is equal to 5, all of it what? Squared. So when I come here and I want to express this in form of a perfect square, means that I can just come and I carry that given value of C. So always first check out, but we are going to work out. I want you to check out and tell me whether this one is also a perfect square. X squared plus 8x plus 16. I want you to type in the chat and tell me that it is a perfect square. It's not. Type quickly. First prove. First find out, is it a perfect square? I'm waiting in the chat. Wow, good. Yeah, oh, it seems other people are not saying that their friends are typing. Yes, it is a perfect square. So still a perfect square, we have said C is always equal to a half B, all of it what? Squared. So our C is 16. And when you look here, you have a half times B, which is 8, all of it squared, by 2, 1, by 2, 4, and you end up with 16. But now, how do we express them in that format? So we have said that in case I have x squared plus 10x plus 25 equaling to 0, and I have known that it's a perfect square, C is equal to a half B, all of it what? Squared. We have said that this is the same as, we have gotten our answer as what? 5 squared. So what do? Where you have 25, I will just come here. Where you have 25 is where I substitute this value of C. So I will say x squared plus 10x plus, I come and I say 5 squared. So the next thing you do, for you did it in a simpler way, because after it is a perfect square, so it has to be in the form of x plus p, all of it what? Squared. So what are you going to do? I'm going to get this x and this 5 here. Then I put them in brackets. The sign on the 5 is a plus. So I will just say this is the same as x plus 5, all of it what? Squared. So here you have expressed it in a square form. Are we together? Are we still together?
Yes.
Now I have this one. Now we have found out that this one is a perfect square. 8x plus 16. Can you also express for me this one? where there is 16, substitute that value of C we have got and then write it in this form. Tell me, what do you have? Tell me, type in the chat quickly. Type in the chat. Okay, I want to see. Perfect. Lena, that is good. Yes. Others, type. So where there is 16, what are you substituting where you have 16? You are substituting for what? Square. Not so? Yes. So meaning afterwards, don't suffer. 4 squared. Don't suffer. Carry the x and this 4 and say this is x plus 4. All of it what? Squared. Hope we are together. Another one. I want to also first prove, is it a perfect square? What about this one? Tell me. What is your A? Someone can tell us what is our A. What is the B and what is the C? What is A?
1.
B?
1.
Negative
8.
And C?
16.
Good.
16.
Meaning our C is going to be
Negative.
B, all of it what? Square. Not so?
8.
So we shall have 1 out of 2 times what is B? Is negative.
We are completing squares.
8. Yeah. So we can reduce by 2, 1, by 2, 1.
That is 4 squared.
4. So meaning I'll have negative 4, all of it what? Squared. So don't change anything, leave it the way it is. Come back here. So you have x squared minus 8x, then plus. What you have here is what you write. Minus 4 squared is equal to 0. Now what is your task? I'm going to get this and this, the ones in brackets. So I'll write my brackets. I say x. Inside I have minus 4. I say minus 4. All of which is squared is equal to 0. I have already expressed in completing square. Is that fine?
Yes.
Okay. Can you do for me now the last one about completing square? I have x squared minus 6x plus 9 equals to 0. I want you to express it in form of a square. Let's do it quickly.
X squared minus, now I think 0 because now then x minus 4 in brackets into x minus 0. In the answer. Look at that one. Try to do it the way he has done it and you see.
X plus 3 squared.
Good. Is everyone getting that?
Yes.
Good. So it is x minus 3, all of it what? Squared. Okay. So that is the first one, when it is a complete square. But what if it is not a complete square? What do we do? Now, when it is not a completing, we are going to the next thing. When it is not a complete square. Now, if at all you find out that if it is not a perfect square, so that's when it is, if it's not a perfect square, what do you do? So, or if something is not a perfect square, for it, we express it in this form, x plus p squared plus q. So for it to be expressed in this format, take an example. Can you people find out, since now we have learned, can you find out whether this one is a complete, is a perfect square or it's not? You tell me. Tell me now. Is it a complete square? It's not. And you tell me why. Find out whether it is or it's not.
It's not.
It's not. Very good. That one is a sign that you have learned something. Now, with the next thing, because we have said that it's not a perfect square, we know that C is equal to half B, but all of it what? Squared. So what is our value of C?
10.
C is what? 10 equals to a half times B, which is 6, all of it squared. And when we work out this, by 2, 1, by 2, 3. So you get 3 squared. And is 3 squared the same as 10?
No.
No, they are not. So when you find out, so are you getting it? When you find that those two are not the same, what are you going to do? I'm going to come back in my equation here. I write it afresh. I say x squared plus 6x plus c plus 10 minus c. So c minus c is a 0. So I'm going to just add a c here. I've added this c and a c. So you add it and you subtract it such that you don't change anything. After doing so, what are you going to do? I'm going to have this one, all of it what? Put in a bracket. What am I going to do? I substitute my c. So I'll have x squared plus 6x plus, what is my c? My c is 3 squared. Then plus 10 minus my c, which is what? Still 3 squared. Now I look at what I have inside the bracket alone. This is what, this alone in the bracket, I do what I did last time. I get this x, I pair it with this. So I will say x, this one will be x plus 3, all of it what? Squared. Don't stress. Squared, then plus what? 10 minus, what is 3 squared?
9.
9.
Yes. Then I can now work out and say this is x plus 3, all of it what? Squared, plus 10 minus 9?
1.
Yes. So now I'm working already in expressing in square. This is already I'm a step towards the answer. Have you understood that? Have you understood? We do another one?
Yeah, we do.
Okay, we do another one. Let's do another one. We can do this one. Okay. Now, what I'm trying is when it's not a complete square. When it's not a complete square. Take an example. I can have another number. I have x squared plus x minus 4 equals to 0. So whenever you first find out, is it a complete square or it's not? If it's not, we can express it in this form. Find out and you tell me, is it a complete square or not? Type in the chat. Type in the chat, is it a complete square? It's not.
No.
Someone is telling us it is sincere. Okay, people are saying it is not. Yeah, we can prove C is equal to a half B, but all of it what? Squared. So what is our C? Negative what? 4.
Negative.
Then a half times B. What is our B?
1.
1. But all of it what? Squared. So meaning I'll have 1 out of 2, but all of it squared is equal to negative 4. But a half squared, I cannot get negative 4, meaning it's not a perfect square. So go back here in my equation. I'll have x squared plus x. Then I'm going to bring in something here. I say plus c. Then I bring back minus 4. I say minus 4. Then I bring back my c. Here I have added, then I will subtract. You add and then subtract. So what am I going to do now? I'm going to have this bracket closed. And I'll have this as x squared plus x. What is my c? My c is the same as 1 out of 2, all of it squared. Then minus 4 minus my 1 out of 2 squared. So now I'll continue. I'll pair up these ones. I'll have x plus 1 out of 2 squared. Don't suffer with anything. Minus 4, then minus 1 out of 2 squared is the same as a quarter. then I equal to 0. So then I worked out. Are we together? Hope that point is clear whenever it comes to completing square. Sincere, unmute.
Okay, I have a question. How come we don't include that x, the x in the middle?
The x, now Sincere, once we expand this x comes out automatically.
Expand this, the x will come back.
The x will come back. When you expand x plus a half squared, this is the same as x plus 1 out of 2, x plus 1 out of 2. So I multiply. When you multiply, you have x squared plus a half x plus a half x, then plus a quarter. So the x is coming, a half x plus a half x is x. So I get x squared plus x plus a quarter. So it is coming out. But now I'm just showing you the easiest way to work it out.
Thank you, teacher.
Okay. So like I've told you, but this one will only work when your coefficient of A is always a 1. So always whenever you find that A is equal to 1, please even clap and say this number is 4 marks. These are my 4 marks. Both of them. Yes.
Teacher, I'm taking you a little back on this.
Yes.
Is it the after the square thing, the negative 4 is equal to a half squared? This step down here, I'm not getting this.
Which step? This one?
No, the next one.
This one?
Exactly.
Like I've told you, what you do after finding out that this is not a perfect square, because negative 4 is not equal to a half squared, what you do, add a c and subtract a c. So when I add 2, then I subtract minus 2. This one is nothing still. So I have not changed anything on the equation. So you add and then subtract the same thing. Whenever you add and subtract the same thing, it means you have not changed anything. Fine? Okay. Now, what if it is not? What if it is not? What do you do? At times you may find out that it is not the same thing. So whenever you find out that it's not, the first thing you do, the first task you have to do is to ensure that you remove the A. You make sure that your coefficient of A is a 1. Take an example. When I have this, and you want to use completing square, this one is not a perfect square. So, and make sure that you make this coefficient of A equal to 1. So how can we remove this 3 from here such that our coefficient becomes 1?
Divide it out.
We divide through by 3. Good. So I will divide here by 3, divide by 3, divide by 3, divide by 3. So divide the 3 throughout. So this 3 and this one reduce, you remain with x squared minus by 3 1, by 3 5. I get 5x plus by 3 1, by 3 is what? 6. Equals to what?
0.
Then here, go on and use your completing what? Square. Okay. Allow me to end here. Now, your task is to do numbers about completing square. But we've provided some work on the e-learning platform. So those who have registered, you'll be able to find the work. Monica, let me take a question from Monica.
So what if the coefficient is not equal to 1? 1 is a counting number, but 1 is not 1.
Yes, that is what I've explained, Monica. I've said first remove that coefficient. If the coefficient of A is not 1, first divide through by that coefficient to remove it. Is it fine? Monica, have you understood? Monica? Okay. Becky? 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 Okay, I'm not getting Becky, so allow me to mute all of you now at a go. Okay, may I ask, Gilberti, are you on the call? Gilberti, you could have your hand. Okay.
Yes, I'm
okay.
here.
Gilberti?
Yes.
Okay, good. Let me pin you here and then she speaks to us. You're most welcome, Gilberti.
Thank you very much. Yeah. Good morning, everyone. I'm impressed with the work you're doing, completing squares, looking at lots of different examples. So, Stephen, I'm not quite sure on what you want me to say.
You can just say anything about mathematics and inspire the young generation.
Okay, so am I clear that this is all pupils of the O-level mathematics who are in our room today?
Yes.
Okay.
Yes.
Well,
yes. You can first introduce yourself.
Yes. All right. Well, I'm Gilbert Verbeek, and I have been teaching secondary school pupils for more than 30 years in Belgium. And at the moment, I'm training teachers in Belgium. And we have a cooperation with some of your teachers in Uganda. And we are looking into the issue how we can assist each other in the world of teaching mathematics. So that is most important thing, I think. And on a personal note, my daughter lives in Uganda. So I'm also very interested in how you are learning in Uganda. And of course, mathematics is very important to perform well, because without mathematics, I think our world is not evaluating. If we didn't have mathematics, we wouldn't be able to talk to each other this Saturday morning like the way we do now. Maybe you don't notice it, but behind all these laptops and smartphones and images we see, there is a lot of mathematics behind it, but too difficult, I think, for the secondary level. So that's why you have to learn, and that we hope that some of you will even continue learning mathematics on a higher level. I think that's the most important thing I would like to say this morning. Is that enough, Stephen?
Yes, thank you so much, Gilberti. So Gilberti is one of our friends, and she's a teacher of mathematics. She's in Belgium, and she's following our programs. So we are happy to have you, Gilberti, and thank you so much for attending this session.
Okay. Keep up the good work, and thank you.
Okay, thank you too. Okay, now we are going in. We are going in for our next presenter. Luther, are you ready? Luther, unmute and you tell us. Luther, are you ready?
Yes.
Okay. So after Luther, we shall have Emilia Joy come back. Okay. You are welcome, Luther.
Thank you. Just a minute. Let me set up.
Okay. Luther, can we have Joy as you set up your mat? Oh, it is done.
Okay. It's okay.
Okay. So you are coming now?
Let her do it first.
Okay. Okay. Emilia Joy, you can come first, then Luther will come in. Emilia Joy?
Yes, please, teacher.
Okay, you can first present. Luther will come in later. After you.
Okay, I'm going to be sharing with you number 76. Okay, so the question to number 76 says, a figure below shows a cone whose base radius is 6 centimeters and the perpendicular height of V is 44 millimeters. So first, from our question, we realize that they have given us different units. The radius is in centimeters while the height is in millimeters. So the first thing I did wait a minute, what? How many animations are in this animation? Just remove all animations.
Let's give her just a minute. As she says, as of well. Yes. So in the chat, there is a link for you to register all those that have attended the seminar. So check in the chat and then fill in that registration link. There is that registration where we are capturing schools that have joined in. And also I want to let you know, in second term, next term, we shall also have another seminar when you are at your school. We shall be inviting all schools across the country to join in the seminar. So we shall be sending letters of invitation, and we want all schools to sit on one laptop, to sit in one class, and then listen in from all over the country. So the link is going to be dropped in the chat. It has been dropped, I know already, but let me pick it. Ronald, in case you are on, you can as well drop it again. So we shall have that seminar. We are preparing you for the final exams. Emily, are we set? Okay. So we are preparing you for the final exams, and we want to see everyone go out of the exams when you have your distinction 1 already secured. We are going to keep on with you. We shall until the last moment when we are praying for you for the success. Math is coming in as one of the first that everyone goes out happily. Okay. Joy, we are waiting for you. Okay, good.
Okay, sorry about that. So our first question told us to find the slant height PV. So to find PV, we are going to use PV, we are going to use the triangle V or P, that triangle that I've tried to highlight there. And to use it, we will need to put the 44 millimeters in centimeters so that we have 1 unit. That's why I've stated here that 10 millimeters are equal to 1 centimeter. That therefore means that 44 millimeters will be equal to 44 divided by 10 centimeters, and that is 4.4 centimeters. We'll continue to find the slant height PV, and we shall use Pythagoras Theorem, which states that a squared plus b squared is equal to c squared. We shall use our 4.4 centimeters plus 6 centimeters squared, which will be equal to c squared. The 4.4 squared will give us 19.36, while the 6 squared will give us 36, and this will still be equal to c squared. When we add 19.36 to 36, we get 55.36, which will still be equal to c squared. So find the square root of 55.36 and the square root of c squared, because what you do on the right is what you do on the left. This finally gives us our answer as 7.4404 centimeters, and that will be the slant height PV. We'll then continue to our next question. We said, calculate the area of the subsurface of the curved surface of the cone. So for the area of the curved surface of the cone, we use the formula of pi RL. In this case, I'll be using my pi as 3.14. Our radius is known to us and it is 6 centimeters, while L is the slant height of this cone, and which we have just discovered is 7.4404 centimeters. When I multiplied 3.14 and 6 centimeters, I got 18.84 centimeters. I further went 84 centimeters with 7.4404 centimeters, and this gave me 140.170 squared. I'll continue to the next part, which said calculate the volume of the cone. So to find the volume of the cone, we get the formula for finding the volume of the cone is a third times base area times height. The base area of this cone is a circle. We are finding the base area, we are finding the area of the circle. And the area of a circle is given by pi r squared. Therefore, we shall have a third pi r squared h. When we substitute this formula, we'll have, which is our centimeters, which is our radius, times 6 centimeters again. Since they said the radius is r squared, I'm expanding it into r times r, and r times r gives us 6 centimeters. Times 6 centimeters. So therefore we have, that's where our 6 centimeters times 6 centimeters comes from. Then after that, we shall also substitute the height, which is 4.4 centimeters. When I multiplied a third times 3.14 times 6 centimeters. I got 6.28 centimeters. I multiplied 6 centimeters, multiplied 6.28 centimeters with 26.4 centimeters squared. I got 165.792 centimeters cubed as the volume of the cone. That's what the question requested for. Any questions?
Joy, we have some questions. Yes, Cynthia.
Okay, mine is not a question, but I'd like to see the question slide. The slide with the question.
Okay, then alapaswaswa. Alapaswaswa animate. Alapaswaswa is not animating. Gloria. Gloria asked. I think I'm losing out on Gloria. May I ask Ben? Ben?
So I would like, okay, some explanation on how I
We have lost. Okay, let's hear from Ezra. Ezra?
Sir.
Yes, please go on.
I would like to have a view on part B.
Okay. Joy, have you picked the question?
Yes, I have.
Okay. Respond to that question. In case you have another question, use the chat.
Part B said that calculate the area of the curved surface of the cone. Okay, so when a cone is formed, when a cone is formed, it has that part that is folded to make it a cone. It normally originates from a part of a circle that has been cut away. So in this case, they're telling us to find the area of that curved surface that was folded to form the cone, that part that they folded so that they could get the cone. And the formula for finding that is pi RL. In this case, we have our pi as 3.14 being multiplied with our R. R stands for radius, which is 6 centimeters, times the L. L is the slanting height, VP, which we found in the previous example as 7.4404 centimeters. When I multiplied 3.14 and 6 centimeters, I got 18.84 centimeters. I multiplied the 18.84 centimeters with 7.4404 centimeters, and that gave me 140.1 771 centimeters squared. Is that clear? There is a question in the chat that asks how I got the L on part B. The L that we are using here is the slanting height, and in our part A, we found the slanting height, VP. So we are using that VP that we found as our L here.
$18.8 centimeters by part C.
Cynthia, may you please ask your question?
Sorry for that. I have no question. I left my hand up.
It's okay. Mercy. Mercy. I don't know if Mercy is with us, but Ronald, you may also ask your question. Several for Ronald.
Thank you. Can I ask?
Yes, you can.
On part B, I have a problem with the pi. I used 22 out of 7, and it's a different answer.
From what I have known, 22 out of 7 isn't exactly 3.14. It has other decimals, so I think it's a normal thing. The answer is supposed to be in about the same range, but it may not exactly appear the same. I don't know, Mr. Kaziba, what do you have to say about that?
Okay. Yes, what you have said, Joy, is very right. But my advice would be, whenever you use 3.14, there is an error. You will get a small error, so you are going to be within the range. But both your answers, someone who has used 3.14 and 22 out of 7, your answers must be very, very close. They are very close. So if at all your answer is not 165 point something close, it means there is something you have not done right. So always your answer will find out that it is within the same range. So those answers. Then what you need to take note of is that when they do not give you a pi to use, always we shall advise that you stick to 22 out of 7. Whenever they don't specify that use pi as 3.14, go on and use 22 out of 7. But once they specify that use your pi as 3.14, then go on and use that one. Then someone was asking about the decimal places. Now, when we are rounding off, never round off from the calculator. Don't round off from the calculator. So Emily Joy, what she has done is very right. So first write to a given number of decimal places. Writing to 2 to 3 and 4 is a good estimation. So go on and first write those decimal places, bit 4, bit 5. Then in case the question specifies and say, now write to 2 decimal places. Then please, after writing this number from the calculator with 4 decimal places, go on and terminate it to the required number of decimal places. But never and never round off from the calculator directly. First, write your answer to a given number of decimal places. The good ones are 4 or 3 and more. Then after, write your final answer to a given number of decimal places in case it has been specified. Do we have any? Okay, those who have more questions, use the chat. The teachers will be able to respond to those given questions. When you check the seminar questions, those who got the seminar questions, you'll find out that all formulas provided. We provided you with most of those formulas concerning a cone, concerning a cylinder, concerning a pyramid. Most of those things are there. So please go on and check out some of those formulas that are there. So go check out some of those formulas, but we shall keep on spreading the news or the gospel on how to work out. Oh, okay, Lina, that L is the slanting length. That thing that is slanting is what is your L. So whenever you open a when you look at a cone is a curved thing. And when you are looking out for the area, when you are looking out for when you are opening it like this, you will notice that for a cone, that one we call it like it's like a circumference. So that figure that comes out for a cone, it is a curved surface. So to get its to get that part, that curved area, we get it as pi r L. So L is that slant length, that longer length. Yes, the slanting one is what is your L. And R is the radius. Okay. Okay, good. Thank you so much, Emilia Joy, for the wonderful presentation. Can we please thank her in the chat? You can write a thank you in the chat. Okay, Luther, you are welcome.
Good afternoon, everyone. We are going to be doing number 22. Let me get the question. Number 22, part C. Because of time, is the only part I'm going to be handling. It says the volume of wood in a tree, V, varies directly as the height, H, and inversely as the square of the girth, G. If the volume of the tree is 144 meters cubed, when the height is 20 meters and the girth is 1.5 meters, what is the height of the tree? Okay, I see people in the chat saying the screen, but I'm not going to display the question on the screen. I thought you had the questions, or I would read them out for those who don't have the questions. Okay, let me start. Let me repeat the question for those who didn't hear it. We are doing number 22, part C. 22, part C of the seminar questions. So they say the volume of a tree, V. The volume of the tree, V, varies directly as the height, varies directly as the height, and inversely as the square of the girth. So we We also know it also varies inversely as the square of the girth, g squared. So after we extract this information, we try to make it one big equation. So this is the same as saying V varies as the height times inversely as the square of the girth. So V varies as the height out of the girth squared, meaning V is equal to, the volume is equal to a constant, we bring in a constant K, times the height out of the girth squared. Are there any questions up to there? Or we can proceed. Yes, Stephen. Stephen, your question, please.
I thought that we give a constant to, since they have said V varies directly as H, we give a constant to H, then V it also varies directly as the inverse of G squared. We also give it a constant, isn't it?
That's when they say these are joint variations, not partial. When you introduce, as you're saying, when you introduce different constants, that's when it's in partial variations. If they say the volume of the tree varies partially as the height and also partially as the girth squared. But here they say directly, these are joint variations. So when they are joint, you join the variations, hence you bring in only one constant. Is that okay? Stephen? Okay, Becky.
It's okay, thanks.
Becky?
Yes.
Your question.
I'm asking, like, how do you know whether it's a joint or a partial variation? I get confused there.
Okay, what I know is that when it's always in the question. Now, when they say directly or jointly, that's a joint variation. But when they say varies partially as this, partially as that, that's a partial variation. That's how you tell the difference. Is that okay? Becky?
Becky, unmute. Becky is failing to unmute. Okay.
Okay, I think I proceed.
Yes, it's fine. You can go on.
Okay, so this wasn't the question. The question wants us to find the height of the tree when the volume is 100. Sorry, when the volume is 1,000 meters cubed and the girth is 2 meters. But in variations, before we can find anything, we always have to find the equation that is connecting all the three. And we found the equation. This is the equation connecting the volume, the height, and the girth. So now we need to find the constant. If the volume of a tree is 144 meters cubed when the height is 20 meters and the girth is 1.5 meters. So let me first erase this. So we use this equation to find the complete connecting equation. So they said when the volume is 144, the height is 20 meters. So K times 20 meters out of, and the girth is 1.5 meters. So 1.5 squared. So you work out for K. 144. Sorry. $144 is equal to 20K out of 1.5 squared. When you use your calculator, gives you 2.25. 2.25. So you cross multiply 2.25, 144 times 2.25 is equal to 20K. 144 times 2.25 gives you 324. Is equal to 20K. When you divide both sides by 20, 324 divided by 20 is 16.2. So K is equal to 16.2. Sorry. K is equal to 16.2. So you substitute that value of K into your equation up there. So the final equation will be V. BV is equal to 16.2 H out of G squared. Any questions? Yes, Pretty. Pretty, please unmute and give us your question.
Pretty, unmute. Okay. Blessing, go on.
I wanted to ask, why is it like our teacher on the answer, he was all like, we have to put the positive or negative side. Why is it so?
I beg your pardon, Pretty.
The question, okay. Blessing, repeat and please.
Like me, my teacher at school was all like, when you're writing the answer, you're supposed to put a positive or a negative. And I see for us, we are leaving it as a positive. Why?
Okay. Yes, Blessing, have you finished asking your question?
Yes, I'm done.
Okay. Luther, first, give your reasoning.
I have never heard about putting a positive or a negative when working out something like this. The only time we are required to use positive or negative is when you're working out something and you have to find its square root. When you're working out something and you have to find its square root is when you put positive or negative. I don't know about how it applies here.
Blessing, can you have your hand raised and you tell us whether you are understanding? I'm not saying there is something you're confusing. Blessing, have your hand raised. Blessing, unmute and you tell us whether now it is clear.
Yes, it's clear. Thank you.
Okay.
Pretty.
Let's unmute. Let's unmute.
I just want I just want to ask the question.
Go on.
Please, we are sorry your network is not so good. May I ask you to type in the chat? Kindly type in the chat and let's continue up. Luther, we can continue.
Okay, so everyone knows how we have reached this point. So let me erase this part and we work out the final part of the question. Okay. So the final part says, what is the height of the tree with a volume of 1,000 meters cubed and a girth of 2 meters? So we have already seen our equation is volume is equal to 16.2 times the height out of the square of the girth. So they say they gave us the volume as 1,000. So we substitute it in is equal to 16.2 times the height, which is unknown, out of the girth 2 squared. So that will be equal to 1,000 is equal to 16.2k out of 4. When you multiply both sides by 4, it becomes 4,000 is equal to 16.2 2K. Sorry, H. Mistake. H. 16.2 H. So when you divide both sides by 16.2, we'll get 4,000 divided by 16.2. So H will be equal to H will be equal to 200. Sorry. 246, yes. 246.9135. That's the height in meters. Don't have space here. In meters. Any questions? Yes, William. Please.
So you've said it's 9135. Why haven't you said 9136?
Oh, my bad. Sorry. The calculator gave us 91358. And when you round off, it becomes 6. Okay. It was a mistake. Thank you.
Any other question? Okay. Luther, is that the last number?
Yes.
Okay. Thank you so much.
You're welcome.
Wycliffe, I'm not getting your question. Can you show how second step? Wycliffe, your question has not been so clear. Okay, thank you so much, Luther, for this technology. So you have seen Joy, Arthur, everyone has used different technology, and this is the kind of things we want to integrate into our education system. Thank you so much, Luther, for your presentation. Today we are supposed to have a school from Chotera, and unfortunately power went on. But now I want to invite some teachers who are on the call to give us a word. I want to invite them to speak to us. I want to invite a teacher from Desta Secondary School. You can unmute yourself and then speak to us. Desta Secondary School. He has been able to have his students online and they have been able to attend. Let me ask you to unmute. Desta Second. Okay. Desta Secondary School. I'm not getting you. Are you on the call? Desta Secondary School. Oh, I think I'm losing. You can have your hand raised, teacher. Okay, okay. Yes, you can speak.
Okay, thank you so much for this opportunity which you have given us. And what I would like to speak to our learners is that use this opportunity of the multiple questions which they have provided to us, that you do more of practice from them, because there are more questions. There are more questions, please. We have, the presenters have just picked a few of them, and it is, the question paper is really a great source of questions. Please, let's do practice from these questions. They have done most of those questions which seem to be simpler to many of us, but let us get the challenging ones and do practice them in groups with our friends at home, those ones who are still home during this holiday. And when we go back to school for the second term, we also do practice discussions such that we really get the perfection in mathematics. Yeah, mathematics is really enjoyable. It's a good subject. Please always love it and practice. So this is Teacher Sebu Ronald from St. Paul and Pauline's SS, Gayaza Masaka. Yeah, I'm also with my learners. We are online. So if they feel free, they can just give a hand of applause to you. Just clap, learners. So thank you so much, Help Schools platform. You have really done so good for us. Thank you so much, learners. Bye.
Okay. Teacher Sevuku, before you go off, can you turn on your video, and we have at least we look at the learners, want to enjoy them also.
Okay. So just viewing everything using our projector screen, you can see that screen. So don't worry, but we are just on a projector.
This is really very beautiful, Teacher Sebufu. Okay, let me, I've seen a clear one. I think this one is much clearer. You can show us.
Yes, thank you so much for that. So we are in class. Yeah, those are our learners. I'm just rotating in one position because I don't want to disconnect the connections, the cables to the internet. So that is it. So we are just in class, enjoying. Our learners are there. My co-teacher is there behind. Mr. Emma, you can wave to our people. Yes.
Okay.
That is it.
Okay.
This is St. Paul and Pauline. You are most welcome, sir.
Oh. Okay, this is very, very, very beautiful. We are so happy, Teacher Sebufu, for bringing all these learners together, and we have really learned a lesson. Other schools, I think, they are going to copy what you are doing, and I think next week, Teacher Sebufu, we are going to continue with these questions, and we shall be very, very happy to have some of your learners present also.
They will present, they will present.
Okay, we shall be very, very grateful. We shall have the discussion during the course of the week, but we shall get a time and we inform you, and then you give us your program, and then we see how we shall have them also present. Thank you so much.
You're welcome, sir.
Okay, I wanted also to invite teacher. Okay. Besta Secondary School, are you on also? Okay, okay, we have teacher Wakaluwa, Daniel. Oh, this is beautiful. Teacher Wakaluwa, you can also show us the learners. Oh, wow, wow, wow. This is beautiful. Thank you so much, teacher Daniel. Let me invite you to say a word to us. Teacher Daniel, you can speak. Your microphone is muted. Oh, let me unmute you. Okay, teacher Daniel, you can unmute.
Yes, good afternoon to you. Mr. Kazi, are you hearing me?
Yes, we are hearing you clearly.
Yeah, nice to be on this platform. I see St. Paul and Pauline's, Mr. Ronald, Dongo, please thank you. We thank your tireless efforts for enabling us get to this seminar. Let's stay in touch for other seminars for the betterment of our students. Thank you, Mr. Kaziba.
Okay, thank you so much, Teacher Daniel. Teacher Daniel, what is the school?
The school is Daystar Secondary School, Wakiso.
Okay, okay, this is the school. Okay, we are happy to have you, and our prayer is next week. Also, you come on board and also present to us.
We have another one next week.
Yes, we shall have another one. We want to complete these questions. So the questions we have not been able to do, we want to complete them within the course of the week.
All right.
Okay, thank you. Okay. I've seen also Twins College in Abingo. Twins College. Can you also unmute, teacher? Twins College in Abingo. Okay. Any other school that is on the call? Oh, but I'm also seeing Immaculate. Immaculate, this is good that you're with your sister. Thank you for joining us. So that is Immaculate. Okay. Do you have any other school in case you are seated in a group and you have your friends you have been able to invite for the seminar? Can you also let us know? You can have your video on and then you wave to us. Okay, let me look at Lydia. Lydia, are you in a group also? Okay, okay, okay. Allow me at this time to welcome Mr. Ronald Dungu to say a word to us as we finish up the seminar. Mr. Ronald, you are most welcome.
Thank you, Stephen. I hope you can hear me.
Yes, you're very clear.
Dear students and teachers, we thank you for the time you've given to this. We appreciate all the discussions that have gone on, and we know that quite a lot of work goes on even before the presentation comes to the screen. And we like to encourage ourselves to do this always. But also we want to plan the school event when we return to school, maybe towards the end of June or early July. We will organize a school event. We did this during the COVID time when the senior fours went back to school in March. We had chance in 2021. Actually, we did it in December 2020. We had a seminar where we brought about 60 schools together. So we hope that the schools that are joining now will also join in then and present. But we also hope that you, the individuals, are going to encourage your schools to prepare for this seminar, and you yourselves are going to be the presenters from the different schools. And what we are working towards is to see that we can have over 1,000 schools joining on one screen, because we want to test the possibility of technology. How can we all learn together at a go? We may have 7 discussants, but then the 7 discussants will reach 1,000 schools. And in the 1,000 schools, each school will have about 100 students. And that will mean that we can have almost 100,000 students learning together at the same time. Do not forget, those who started with us this morning, I showed you a platform where you can go to find more notes, where you can go to find these links, and we shall be sharing these within the WhatsApp groups. So we encourage the teachers to join the WhatsApp group so that we can share with them. Teacher Stephen, maybe the teachers need to contact with you such that we always link up with them going forward. But I want to thank all of you and to thank Teacher Stephen and all the other teachers who have been on the call for making this happen. And in the week, when we go to complete the questions, let's all join in actively and we continue solving the mathematics. I thank you, and over to you, Teacher Stephen.
Okay, thank you so much, Teacher Ronald. I want to also thank all the students who have put in a lot of time to make the presentations. We are really very grateful. But before we go, let me emphasize some of the key topics that you need to be knowing. Mathematics is a subject of working. You need to work in order for you to get ready. Before you go into the paper, ensure that there are some numbers you have at your fingertips. There are some sections that you have at your fingertips that you cannot fail. Whenever you are entering into paper 1, let me start with paper 1, there are some sections that are going to appear that you must be able to do. One of those sections is what we call statistics. You will always find a number of statistics in paper 1 and in paper 2. So in paper 1, those are 4 marks. Sorry, in section A, those are 4 marks. In section 2, those are also 12 marks, meaning that those are 16 marks. You are going to find a number about trigonometry. That is section A, section B. Those numbers, you must pass them. So I'm only talking, that is now on when I'm talking about paper 1. So I want you to start now preparing. Those seminar questions have been well designed. They have to be, if at all you go in, by the time you go in for mocks, ensure that you know all those questions, you can attempt any of those numbers. When it comes to paper 2, there are numbers that you must be knowing. A number about functions and mapping. Let it be at your fingertips. But all there's anything, you're doing a number of function and mapping. You get in section A, there is a number, those are 4 marks. In section B, there is a number, those are 12 marks. 4 plus 12 is 16. You passing a number in paper 2, passing that number of functions in paper 2, you are already sure that you have 16 marks. So on that number, you're going to add on a number about set theory. That is in section A. So in section A, first pass those 4 marks. First get those 4 marks of section A about sets. Then in case you are strong, then you can do the one of section B. Still in paper 2, there is a number about vectors. This I'm talking about compulsory numbers, numbers that can never miss in any of the papers. If I told you have interacted with any of the papers of math and you have not found those numbers, then no, that is not a standard paper. So you never miss that number. I've told you, you have to master a number of functions and mapping. That is a sure deal. It is going to be a number of your choice. I want you to put more emphasis. I've said functions and mapping. I want you to put emphasis on what you call dimensions, the 3 dimensions. I want you to put emphasis on business mathematics. That is to say taxation, interest and commission, exchange rate, discounts, percentages. For vectors, first go for the number that is in section A. First do that number that is in section A. If at all you are strong, you have made a lot of practice, go on and do the numbers you have in section B concerning the vectors. I want you to have emphasis on the number concerning proportions and variations. Those are key numbers that you always have to do. In paper 1, I want to give attention to statistics, give attention to matrices, give attention to probability and set theory, and then also give attention to quadratics. With those numbers, you have already credit 6 pocketed in your bag. I've told you in section A, I want you to be working for only first work for the 20 marks in section A. Go to section B, work out pass only 2 numbers, that is 12, 12, that is 24. You passing the sum 5 numbers in section A and passing 2 numbers in section B, you have already credit 6 and above. What are we fighting? We don't want to see any child getting or scoring an F9. We don't want. That's why we are going to work tirelessly until we see that everyone can get a distinction in mathematics. So in next week, our major emphasis is going to be statistics, is going to be matrices. We are going to do trigonometry, we shall do vectors, and ensure that by the time you go into your notes, all those sections are well captured. We are going to send questions about those topics. We are going to send some notes about those given topics through your teachers. Your teachers are going to deliver them to you to be able to work out. When it comes to mathematics, make sure you do a number every day. Never go to bed when you have not done a number of mathematics. Ask your teachers to give you those numbers of mathematics. Work out every day. With time, you're going to see that mathematics is becoming very easy. I want you to work on a principle we are going to be calling the 5 P's. The 5 P's, I want you to have that principle captured, 5 P's, and those 5 P's, the first P stands for prior preparation prevents poor performance. That's why we have started these seminars early. Prior preparation prevents poor performance. So let us work tirelessly. Let's work and use the time very well. Otherwise, I want to thank you so much. Allow me to first call on Tribuna. College Nabingo is also on the call. Let me ask them also to say a word to us, and also let me invite them to have their video turned on, such that also they I've said prior preparations prevents poor performance. Twins College Nabingo, teacher Flavia, you can have your video turned on and then see what is taking place. Twins College. Teacher Flavia, are we losing you? Flavia? Okay, it seems we are failing to. Okay, but we want to thank all those schools that have joined in on the call. We are really very, very grateful. Please don't sleep when you have not done any number. Don't sleep, don't sleep, don't sleep. When you don't have the numbers, please let us know. I'm seeing St. John's Comprehensive. Yes. Can you unmute, teacher? St. John's Comprehensive. Okay, let me put lights such that people can be able to see you. Okay. This is very good. Okay. St. John, yes, you can talk, class teacher.
No?
Go on, go on.
Yes, I'm not a teacher, but we have been students and we have converted so that we can do seminar.
Okay, can you turn on your video? St. John?
We have been on a projector, but I'm trying my level best.
Okay, okay. Let's give them some minutes. So when you visit the website, you are going to find most of those topics. Teacher Miingo Emmanuel, I'm happy to hear from you. Thank you so much for the great work you are doing. Okay, so this week we shall continue with our lessons. The timetable is going to be sent in your WhatsApp groups. So keep checking. It's going to be sent tomorrow of the lessons we shall have. We are going to continue having different seminars. We shall have math. We shall have some chemistry. We are going to have still some biology. So please, whenever you have time, keep on attending such that you can be able to learn. You want by the time you go back to school, when you are really competent and you are ready to do your exams. Okay. Okay, I'm just waiting for St. John's. Okay, I'm going to ask St. Paul and Pauline to get for us a student who is going to lead us in a closing prayer. Okay, Priscilla and Shema, we are happy also to have you. And take it, Emmanuel, Immaculate, also that is good. Okay. Okay. St. John, are we getting you? Okay. Okay. Teacher Daniel, have we got a student who's going to lead us in a closing prayer? Okay. Good. Okay, you can start.
Name of the Father, love of the Son, love of the Holy Spirit, and oh dear Lord, we thank you for the gift of life. We thank you for the time you have given us within this seminar. We are asking you to help us with our teachers so that we can pass well. We thank the time you have given us with the cooperation in the seminar with the teachers who try to help us explore our potential so that we determine the future. Lord, help us in whatever we are doing so that we can succeed in this life through our education, which is a journey of 1,000 miles. God, help us in whatever we are doing so that we can succeed in this world. God be the Father and to the Holy Spirit, as it was in the beginning, is now, and ever shall be.
As it was in the beginning.
May the grace and the love of God and the fellowship of the Holy Spirit be with us all, now and forever. Amen.
The Father and of the Son and of the Holy Spirit.
Okay, thank you so much, Saint Paul and Paul. Thank you, Claire.
Yes.
Okay. Okay. May I ask everyone to have your video on, and we are going to take a photo. We are going to take a group photo, so you can have your video turned on, and also you can have your microphone.
Bye.
Okay.
Thank you, Mr. Kagawa. May God bless you abundantly.
Bye.
Bye, everyone.
Bye.
Bye, everyone.
Bye.
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 Bye. Ronald, let me hope you are taking some photos.
Bye.
Oh, I'm on a phone. I can't take.
Oh. Okay.
Oh.
Okay. This is nice. So let's meet next week. Thank you. Okay. Bye, everyone. See you next week.
Bye.
Bye.
Thank you all.
First, you're going back to holiday.
Okay. Bye.